Duple meter. Thanks for joining me for this video about duple meter as explained in my book Ski Hill Graph Pedagogy, Meter Fundamentals, available on Amazon and other retailers. This video delves into duple meter and the recent redefinition of meter by Richard Cohn from Yale University. It explores how listeners experience duple meter in music and offers insights on effective teaching methods for this concept. So what is duple meter? Most music textbooks and online resources define duple meter as 2/4, the time signature, also known as a meter signature, at the beginning of a piece of music. Contemporary definition of meter acknowledges meter is more than time signatures and includes the listener's response to music. Cohn defines a duple meter as a relation of two pulses true to one, a phenomenon initiated from listening to music. These pairs of pulses occur at different divisions, faster or slower. The meter makes us move and contributes to music that moves us to feel emotions and memories, and so much more. Yet most music theory would have us understand meter as a time signature and group of only one type of pulse, notated or written in measures, such as the following illustrates. Teaching and learning meter is best approached from listening to and responding to music, because music is sound, and the meter is such a critical part of the experience of music. Listening to music generates numerous pulses or segments of time, each of which can be represented through ski hill graphs. These graphs help summarize the pulses and connect pairs of them as either duple meters 2 to 1 or triple meters 3 to 1. This ski hill graph illustrates details about meter, specifically the mathematical elements of meter that are not encompassed within the 2/4 time signature. This ski hill graph illustrates two pulses 2 to 1, that is, the mathematical aspects of a duple meter. Each circle represents a pulse, a division of time, with the top circle holding twice the length of the circle descending to the left. A set of two pulses 2 to 1 is called a minimal duple meter. Minimal because it is the least amount of meter possible to experience. A set of two pulses 3 to 1 is called a minimal triple meter. While it is important for teachers to understand two pulses 2 to 1 or 3 to 1 is a minimal meter, for young students it is more important to understand the relation between two pulses for later studies with further divisions. For instance, each circle or division of time can be represented with a fraction. These two pulses, 1/1 and 1/2, or 1 and 1/2, are experienced as the relation 2 to 1. Each division of time can be represented with a note, such as the following crotchet and quaver, depending on the piece of music and the pair of pulses you are identifying and wish to represent. The number of pulses and meters music initiates is known as the depth of the meter, because listening to music initiates many sets of pulses 2 to 1 and or 3 to 1 minimal meters. The meter from listening to a piece of music is described as deep meter rather than minimal meter because more than one pair of pulses is experienced listening to music. Young students need only focus on the meaning, experience, and mapping of meter rather than the meter terminology until they're ready. The following ski hill graph illustrates a listener-acknowledged and mapped 5 pulses and 4 duple meters. It is important for students to understand that a meter from listening to music is made up of many layers of minimal meters. This ski hill graph shows 2 pulses 2 to 1 among the many possible other divisions. The slowest pulses are towards the top and double descending to the left and triple descending to the right. The best way to understand how ski hill graphs work in teaching meter is to introduce minimal duple meter and triple meter, Then add to this other pulses and meters, or deep meter. The scale graph is suitable to introduce with most teaching approaches to extend meter understood as a time signature. To teach minimal duple meter, you can introduce the three-step approach of ski hill graph pedagogy: clap, tap, and map. From listening to a piece of music which only initiates duple meter, ask your students to clap each pulse, tap each meter 2 to 1, and map each pulse and duple meter through a ski hill graph. The following example for younger beginners of music, which initiates duple meter, is an excerpt of the song Twinkle Twinkle Little Star. Listen without looking at the score. Let's listen to an excerpt of Twinkle Twinkle Little Star. While listening to the music again without the score, ask your student to clap each regular pulse they can feel. You may need to guide the student by modelling the clapping until they learn this meter listening skill for themselves. The pulses don't have to be clapped in any particular order. During teaching, if you need to model clapping pulses, work in collaboration to see if the student can identify new divisions or pulses. For example, can you hear a longer pulse? Or how about a faster pulse? When the student has identified two pulses where one pulse is twice as fast or twice as long as the other, ask the student to tap these two pulses 2 to 1 at the same time. Teach your student this important meter listening skill if they need to learn how to perform the two pulses, and encourage students to practice this at home. Try gently knee tapping. Use a chair or a closed piano lid if you permit fingerprints, and one clap to 2 steps 2 to 1 can work well with very young students. Establish a minimal meter is a pair of pulses, the least amount of meter, and a minimal duple meter is pulses 2 to 1. Tap 2 pulses 3 to 1 to contrast a minimal triple meter if you feel this is an appropriate time. Triple meter is the topic of the next video in this series. Map the set of 2 pulses your student clapped and tapped 2 to 1. Ensure your student maps in their own handwriting on their book or a whiteboard, and you can model mapping as they learn. Encourage the students to practice clap, tap, and map at home before the next lesson. If the student is very young, parents and guardians who assist the children can introduce creative ways to relate the fractions 1/1 and 1/2. Creativity is the key to success in teaching, and the ski hill graph fractions can be applied to other meter teaching tools such as circle graphs to assist students' development of their mathematical intuitions. The ideas in the following section can be introduced gradually as the students show readiness. A pair of pulses 2 to 1 is also known as C2 or a 2 cycle, as the fastest pulse, the unit pulse, is equal to 2 counts or time points. The longest pulse is called the span pulse. 1/1, or the counting number O, is the span pulse, and the pulse twice as fast, the half, or O1, is the unit pulse. We can pronounce 0 as O to avoid the double syllable initiating another pulse division. Visualizing the mathematical aspects of duple meter assists students to learn more about their musical intuitions. The meter is cyclic and hierarchical. Each division or pulse can be represented through a circle graph. The longest pulse is shown as a complete circle, while a pulse that measures half the length of the longest one is illustrated by a diagon or semicircle. People of all ages and abilities relate visualizations of ski hill meter mathematics to geometry. The lesson ideas presented here are very flexible and should be adapted to your student cohort. Much of the first part of this video occurs briefly as part of a lesson. However, you may wish to spend more time on minimal meters before moving to deep meter, where further pulses are added to the skill graph. If the piece you listen to is one the student is preparing for performance, moving from minimal meter to deep meter will ensure the student has the maximal amount of lesson time to play their instrument. In this way, the student will be equipped with the skill information they need to understand the timing and to inform the expression. While listening, continue to clap each pulse at different divisions. Some students may easily identify different pulses, while other students will need extra help. The resources I provide begin with the smallest Duple meter cycles and those practical for beginners. And tap each pair of pulses 2 to 1, minimal Duple meters. Next, map the pulses through a skill graph, adding 1 pulse at a time. This skill graph illustrates a student clapped 3 pulses and tapped 2 Duple meters. Once your students understand the relation of one set of pulses 2 to 1, 2 or more adjacent sets 2 to 1 is an intuitive expansion of the concept of a minimal Duple meter. This skill graph represents deep Duple meter, and students will soon be familiar with these concepts and able to label them in their own time as applied to music listening and performance. The addition of another pulse 2 to 1, a new division 1/4, is a Duple division of the slower adjacent pulse 1/2. The new unit pulse or fastest pulse 1/4 means the meter is also called C4. The line or edge between each adjacent node or pulse visually connects the pulses as meters. The skill graph meter information is then applied to performance preparation of timing. Counting or beat class based on the meter cycle, here C4, is annotated under the notes. Beginners reading music for the first time benefit from beginning with small cycles such as C4. The counting for each note performed is circled and a line is added for the longer notes. The counting annotations assist the student with eye tracking during reading the notation and performance. The skill information is also applied to inform expression. The vertical stacks of pulses above the notation enable students to learn more meaningfully about expression and how meter and dynamics, or volumes, connect. Students relate the skill meter mathematics to the music volumes 3, 1, 2, 1 as strong, weak, medium, and weak. These first steps provide a solid foundation for the next stage of development when students add further pulses to the skill graph and their performances, such as hyperpulses. This skill graph illustrates the student added 2 more pulses, 2 hyperpulses. The student performed the piece over 2 and 4 measures to acknowledge the phrasing by connecting the skill meter information to inform their performance preparation. Not only does the skill graph illuminate the nuances of timing and expression beyond the confines of time signatures, but it also fosters critical thinking and problem-solving skills. While students may grasp the pitch they need to perform, the realms of timing and expression often present challenges. Cohn's skill graphs guide students in understanding when and how to deliver each note, nurturing their confidence in performance. Cohn's skill graph is a wonderful addition to music theory, specifically for meter fundamentals, to assist students to understand meter's mathematical aspects deeply through a more meaningful approach than time signatures. The skill graph is a welcome inclusion for beginner lessons on meter because the meter mathematics visualizations provide powerful scaffolding for learning experiences and knowledge of music and mathematics. In my book Skill Graph Pedagogy, Meter Fundamentals, you will find much more information about meter to apply it to performance through skill graphs and to other representations of meter to benefit student learning. The next video in this series will explain triple meter